All right, welcome to Sensors class. We're doing our book review starting with chapter 9. Today we're going to focus on pressure. So we're going to be reviewing chapters 9 through 12. Now let me just say at the beginning, everything in this section is pretty good. This is a lot you're going to run into, especially for process manufacturing applications, such as food and pharmaceutical facilities. So we have a few of those around here, and like UTS and so forth. So measuring pressure becomes a very big deal. But you're also going to find pressure measurement in many other facilities as well. Anytime you have industrial steam, or anytime you have any kind of manufacturing process, you're probably going to be measuring pressure somewhere. So let's dive into this. Chapter 9 is some pressure overview stuff. And it gives you the basic relationship between force and pressure. And it gives you the two, actually they call it three, but there's two most important formulas for converting from force to pressure using area. And the two most important formulas are P, or pressure, is equal to force divided by the area, and force is equal to pressure times the area. So these are your two most important formulas. Generally speaking, we're going to speak of pressure in terms of US measures such as PSI, which is pounds per square inch, which is a unit of force, pounds, divided by the square inches that you're pressing on. They give you a couple good examples, so you should be able to step your way through these examples. If you can't, then get back with me, and then we're going to review them together in a mini class where we'll do a little bit of math there. So fluid pressure, don't forget we're using the word fluid very flexibly. It's not just a liquid, it's any gas as well. So this book talks about fluid pressure as a generic thing, liquid or gas, because gas is a kind of a fluid. The key definitions in this section are here. And oh, by the way, it gives you some lovely graphics here talking about how pressure works. For everybody in the fluid class, this is very much a reminder. If you are not familiar with how pressure works, then read through this and then read through the descriptions. First definition is atmospheric pressure. That is the pressure of the atmosphere all around us. We use a generic 14.7 psi as our generic atmospheric pressure. Almost everything we are going to measure, though, in mechatronics is gauge pressure, which already takes into account atmosphere. It's not an absolute measurement. It just measures the internal pressure, like of the tank, versus the external pressure of the air around us, like the atmosphere. And it doesn't care what the atmosphere is. We use gauge pressure even if we're well above sea level. We might find ourselves up, in Gettysburg, we might be several hundred feet above sea level, but we're still using gauge pressure just very happily. Head, very important term. It's the actual height. It's a measurement of height of any column of liquid, usually associated with water, but it can be associated with any kind of liquid. Hydrostatic pressure is just the pressure related to water, usually water, but they apply it to any liquid as well as mercury. And this is a little diagram showing you how you would measure fluid head, which is just the distance from the measuring point to the top of the fluid. And it doesn't care whether that fluid is what the volume of the fluid above it is. It only cares what the head height is. That head height then is directly related to the pressure. So this is an important concept that we've already talked about in other classes. If you have some trouble understanding this, then we need to stop and go through that. As well, in this book, we talk about Pascal's law, which basically says that pressure applied to a confined state is transmitted equal intensity throughout the fluid and at right angles to the surface around us. It goes through a few different examples of how we can use fluid pressure to, in this case, push a cylinder or create force on a cylinder head. I'm not going to step you through that. They're pretty obvious. Now the scales, pressure scales, that's how you measure pressure. They do mention absolute pressure. Absolute pressure is the internal pressure, whatever you're measuring, versus absolute zero or a perfect vacuum. Nobody really uses absolute pressure except in the scientific community. Gauge pressure is the thing you should know. If you see PSIG on any meter, it stands for pounds per square inch gauge, which is virtually every meter you're going to run into in mechatronics. Vacuum pressure is basically a state of vacuum, which is less than atmosphere. You can have a perfect vacuum, theoretical perfect vacuum, which I don't think is easy to achieve. It takes all of the molecules out of the air. Differential pressure just means the pressure difference between 2 points. Here on this part of the book, and actually my book is defective, it's got a giant smear on it, we can see that it gives you a little graphic of what the different pressure scales are. So, like I said before, the main pressure scale you care about is gauge pressure leading to vacuum pressure. We don't really care about the absolute pressure, which starts way down here at zero or complete perfect vacuum. So the further up a mountain I go, the less pressure I get. So that's why atmospheric pressure has to be set at a generic level, and that's why we're setting it at generic sea level. However, we know that atmosphere changes from time to time. With a big storm front coming in, I might have a drop in pressure. Ahead of that leading storm front, I might have a drop in pressure. When I've got a nice warm period coming in, I might have a rise in pressure, and that's how barometers work. It's a little bit of a short-term weather forecasting tool based on how atmospheric pressure changes where you are. And if you're very experienced in using a barometer, you know when to run for shore if you're, say, a sailor and you see a big drop, a sudden drop in your atmospheric pressure, you know a big old storm front's coming your way. All right, so that's all I'm going to say about that chapter 9.